Okay, Alhamdulillah. All right. So let's continue our lessons. But let me do some recap on whatever we learned yesterday. Okay, so let me share the slide first. Okay, can you see the slide?
Yes.
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 Okay, thank you. Thank you for your feedback. All right. So let me. Okay. So this is chapter 3. Okay, don't be afraid. Right. So because in chapter 3 we will learn about vectors. Okay. So in physics that's normal when you go from one chapter to one chapter, you jump to another chapters. Okay. So after chapter 1, after we finish chapter 1, then we go straight to chapter 3 because in chapter 3 we will learn a lot in terms of vector quantities. Okay, because in vector quantities we will apply this vector inside every chapter, almost every chapter in physics. Okay, that's why it is very crucial, this is very important for us to understand or to learn vectors first before we can go to the motions or maybe to the force, momentum, whatsoever, because this is the main part in physics. Okay, after we learn about units, after we learn about measurements, then we need to learn about vectors. Okay, so I believe that all of you already watched the pre-recorded video, hopefully. Okay, because that is the important thing of this part. Okay, because in here we want to learn about the properties of vectors. Okay, not just a vector, not just a normal vector or what you did in advanced, for example. All right, so vectors, okay, has a scalar and vectors quantity. Okay, definitely vectors. Okay, in the measurement we have scalar and vector quantity. Okay, scalar means, okay, right, scalar means okay, a quantity with the magnitude only, where the vector quantity has both magnitude and directions. Normally students tend to memorize all of this. Okay, it's good. Okay, but they can easily tell you, okay, the vector quantity is what, but they didn't know the exact meaning of magnitude and direction, because the direction here, although it is a simple, it's just one simple word or simple words, but it means a lot here. Okay, because magnitude, is all about measurements. Okay, pengukuran, magnitude is just a value, but in terms of direction it can tell you in terms of maybe left to right. Okay, a simple direction of left to right, top to bottom. Okay, or we can use theta. Okay, in here we can also use direction as theta. Why? Because in the Cartesian coordinate we have 0. Okay, we go here until 90 degrees, 180 degree, 270 degree, and goes back to the original positions at 360 degree. So at one full circle equals here about 360 degree. 360 degree is a degree. So it is also, okay, it is also part of the directions. We can tell directions by giving an exact amount of theta. Okay, so apart from that, we can also use here a compasses. Okay, a north, west, north, south, west, and east. Okay, a simple one. Okay, but not just that, we also have a northeast. Okay, southeast, southwest, northwest. Okay, and you should know by now, if you are given, let's say, 20 degree south of west, how to measure it. Okay, how to measure it? Definitely, when you look at south of west, go, this is north, this is west, and this is south. And how to put 20 degree? because it relates in terms of what we want to learn today, because we want to learn about components. In order to know components, we need to know where is our angle. Okay, so in here 20 degrees is where. So okay, for those who can't remember what they learn in the modern maths, okay, in your secondary school, all right, the south of west should be the angle from, okay, taking here, okay, baca daripada belakang, at the back, from the back, okay, it start with the west to south, it should be here, from west to south, so therefore 20 degree is here. Simple. South of west. Now you need, when you want to put you want to trace it on the Cartesian coordinate or on the compasses itself, okay, so you have to read it from the back. Okay, west to south. The angle should be from west to south. So if it's given 10 degree north of east, then you learn and you read it from east to north. The angle should be 10 degree from east to north. Okay, simple. Because I want to highlight it, because sometimes it will give us some indicator. Okay, where is our understanding in terms of this? Okay, so now you know about scalar and vector quantity. Okay, and basically all the basic quantity should be inside the scalar quantity. Okay, but we also have derived quantity in the scalar quantity, but don't worry, because that is because of how they get the value of derived quantity, because we just know that the derived quantities on the basic quantity is just L, M, T, temperature and current. Okay, temperature and current. Okay, temperature and current. So I get this round because I circle it because this one we didn't learn it here, but we only focus on L, M, and T in the dimensional analysis. But apart from this value, then if we call it as a derived quantities. So derived quantities is also for the scalar quantities, and of course in the vector quantity. So every time you see the components that have directions, definitely is it a vector quantities. And for example, we have a distance and displacement. Okay, distance and displacement. Distance is where we get, okay, it is a total distance travel, the total travels of the object. Okay, how it travels from A to B. Inside our tutorial, I also explain about how to calculate the distance and also displacement. Displacement is a matter of final position minus initial position, regardless of where it should be. Okay, so for example, like in the Olympics just now, okay, one complete one complete one complete let's say velodrome is equivalent to 250 meters, for example, 250 meters. Okay, so at one point, let's say from here, okay, it starts from here. Okay, our Dato Azizul, okay, starts from here and circle it until it comes to the original point. So he traveled 250 meters in terms of distance. But in terms of displacement, remember that the final point minus the initial point, therefore the displacement zero, because okay, he traveled from from the point and goes into the same point. Okay, same point meaning that 0 minus 0, so the displacement will be 0, because displacement only cater about the final position and the initial position. But the distance, where we calculate every point on the travels. Okay, right. Now we go to the next part. Okay, a vector is represented by an arrow. Okay, I hope that I think everybody knows about this already, because when you talk about vector, we need to put an arrow to the consonant. Okay, for example, vector A is considered just this is just A. This is just a normal A, but this one is a vector A. Okay, you need to put the arrow. Okay, if you didn't put the arrow, then it should indicate another terms. If you tells others about vector A is 4i plus 3j, then you will get wrong because this is not vector A. Okay, then you should put arrow, right? The equalities of two vectors. So basically, vector is just a matter of simple. Don't be afraid of the vectors. Vector is just a matter of measurement that have direction. Measurement that have direction. For example, when you have an arrow like this, okay, you measure it with a ruler. Okay, you measure it with a ruler. Okay, then you get maybe 10 centimeters. Sorry, 50, 50 sorry, 20, 10 centimeters. Okay, 10 centimeters, for example, 10 centimeters length. Okay, but that is only measurement. So when you include the 10 centimeters towards northeast, for example, okay, so then it becomes vector. Simple. 10 centimeter to the right, then it becomes vector. 10 centimeter to the left, then it becomes vector. But if you put just 10 centimeter, that is only scalar quantities. Okay, simple. All right. So just now or yesterday we learned about adding vectors because this is part of the solving. Okay, solving vectors. Okay, when you want to solve vectors, you have we have two things. First is through the graphical methods. In graphical methods, we have tip to tail method, tip to tail method, and also we have parallelogram. Okay, tip to tail method and parallelogram. Okay, so this is where you want to use a tip to tail method. Okay, because we may have a certain situations here. Okay, for example, here. Okay, let's look at the figures here. We have vector A and we have vector B. Okay, okay, now you draw a vector A. At one point, you stop here, then you give another Cartesian coordinate over here, then you draw a vector B. Okay? Just after you draw vector A. Okay, at the point at the tip of the vector A, now you draw a vector B. And then the resultant vector should be from the uh, uh, the tail of the vector A, the tail of the vector A, until, which is here, the tail of the vector A, until the tip of the vector B. Okay, so that will be the resultant vectors. Okay, resultant vectors. But for those who want to use, but because of this only occurs to two vectors, A plus B, just two vectors involved. Then is it divisible, or you can use tip to tail method, or maybe you want to use parallelogram because it only involve one vector. For example, this is vector B. Okay, I didn't use the scale, so should use the scale before I draw it. Okay, let's say this is vector A. So what is parallelogram? Parallelogram is the one that you want to do like this. Okay, you extend it like this, and then you give from this part. Okay, from here, now you draw some line. Okay, obviously I'm using my free hand, so it should not be really good in terms of accuracy. Okay, so this should be the resultant, and this is the parallelogram. Okay, but bear that in mind. When you use a parallelogram, it only can involve one or two. At least the maximum number of vector that you can solve is only two. A plus B, okay. But if A plus B plus C, then you may not have. It is not advisable to use parallelogram. Okay, you need to use tip to tail method. Kena guna method yang satu lagi. Why? Because in parallelogram, it only involve, okay, we need to draw a parallel line. Okay, parallel line. So parallel line between two vectors, that is okay. But when you deal with a lot of vectors, okay, a lot of vectors. Okay, vector A. For example, the next figure, vector A, vector B, vector C, vector D. How come we can solve it using parallelogram? Definitely no. Okay, so you need to use a tip to tail method. Tip to tail method. So this is the tip to tail method. Vector A. Now here we we draw a vector B, and at the end of the vector B, we draw a vector C, and at the end of vector C, we draw vector D. And finally, we get the resultant that A plus B plus C is here. If normally in the resultant, we just put a different arrow, two parallel arrow like this, just to show that it is a resultant one. Okay, so that is how you learn physics. All right, so when you use a graphical method, number one, now please use a correct scale. Correct scale. Okay, you need to use a correct scale. For example, here, okay, you need to use the correct scale. For example, in here we have vector A 5 meters, theta is 60 degree above the x-axis. Okay, so 5 meters, how to draw 5 meters on our paper? Definitely impossible. Okay, so you need to highlight this one, that the scale is 1 centimeter equals to 1 meter. Okay, so you need to do some scaling. Therefore, use your ruler. Okay, use your ruler to draw a 5 centimeters. Definitely, you must draw 5 centimeters long. Okay, when you are dealing with the graphical methods, 5 centimeter is a must thing you must draw. Okay, you need to draw correctly. That's why you need to use a ruler. And then, of course, when it involves the theta, it involves the degree, the angle. So you need to follow. You need to use a protractor. You need to use a protractor, jangka sudut. Okay, so you put your protractor over here. Okay, to see where is the 60 degrees. Then it shows like this. Then you can draw with the 60 degrees. Simple. So that is how you determine, or how you can. Then afterwards, for vector B, because we know vector C is A plus B. Okay, vector A plus vector B. So therefore, at vector B, you draw another imaginary. Ini bukan betul imaginary. Imaginary like this one. Okay, like this one. So this should be your Y or your X. And then you now 4 meters. So you need to draw 1 centimeter equals to 1 meter. So this one is 4 centimeters long. And then of course, you need to put your protector over here. So to find the theta, 20 degree to get the P. And then of course, the resultant is from the tail of the A until the tip of the B. Okay, you draw a straight line and you calculate the exact length of C. The exact length. For example, if the length give you maybe 8, in this case 8.7 5 centimeters. Okay, then the answer is 8.75 meters. Okay, and then of course, okay, that is only magnitude. How about directions? Theta from the x-axis. This is the angle of the resultant vector. So when the vector quantity is complete when you give the exact value, okay, which is 8.75 meters, okay, together with the theta. Why? Because theta is considered to be the angle. An angle is part of the direction. Vector quantity needs magnitude and directions. Okay, vector quantity needs magnitude and direction. So therefore, you can see the final answer 8.75 meters, theta equals to 45 degrees. So based on the drawing. Okay. So in here we get the sum of vectors, which is A plus B will be also equals to B plus A. Okay, but subtracting, okay, as usual, subtracting is A plus with negative B. What is negative B? So if you have vector B over here, this is your vector B, and vector negative B is the same length but on the opposite direction. It's just opposite directions of original one. So if B is going upwards, so for example, it will the details of the vector will be shared to you. Okay, for example, B is going something maybe 30 degree above x-axis, for example, 30 degree above x-axis. Definitely negative B is against one. Okay, so against the B. Okay, it's just a matter of direction. But in terms of length, for example, if you calculate or if you draw this one 3 centimeters, this one is also 3 centimeters. Okay, simple. When you want to draw a vector B, you must be make sure that the length is the same. Because it is not because of the negative is not because of the value, but in terms of the directions. Okay, the value must stay the same. All right. This is one example. I already tell you yesterday, if I'm not mistaken. Okay, a car travels 20 kilometer due north. Okay, going upwards here. Okay, this one is very very good. If you can put here, if the question asks you about the if you look carefully, okay, the Cartesian coordinate is just x and y. Okay, x and y, x and y, but in the questions discussing about north, okay, west of north. So is it good if you can draw some indicator? Okay, draw some indicator. North, like the one that they did here, north, west, east, and south, just to make sure that you know where you want to, where you want to do, where you want to, you know where your guidelines. All right, so that's why is it good. But if the question doesn't involve any compasses directions, then it's okay. You have to use just x and y. So that's why in physics you must be very analytical. You look at the questions, okay? Don't just jump to the, but you must read the question properly. Take out every informations, take out or try to pick point. Where is our strength? Where is the question? The need of the question. Okay, we need to, okay, then you calculate using a graph. Find the magnitude. Find the magnitude and directions. I remember they always use this one, magnitude and directions. But maybe, okay, in the questions sometimes they tend to calculate. That's this one. Calculate A magnitude. Then you calculate, and part B, directions of vectors. Okay. So when this one happens in your questions paper, so don't be don't be surprised about it, because sometimes they want to help you. Okay, first of all, you calculate the magnitude. If you have already calculated the directions in the magnitude part, just copy the answers, copy the same answers in here. Okay, don't just please refer, don't just write down, please refer to the part A. No. Okay, then your examiners will give you wrong answers. Okay, because you are so lazy to write down the same answers, although you have calculated in the magnitude part. Okay, so please bear in mind. Right, so using a graph paper, find the magnitude and directions of a single vector that give the net effects of the car strip. Okay, so due north, first due north, just straight away, say this one is north. Right, in here we need to do some imaginary compasses, imaginary Cartesian coordinate at the end of the vector A, which is 60 degree due 60 degree west of north, west of north. So now we read from the back. Well, we read from north, so that's why the 60 degree should be here. 60 degree is in between north to west. Using a graph, okay, find the magnitude and directions of single vectors. So normally people, when we are dealing with the graphical methods, okay, obviously, okay, you need to use the exact scale. Okay, in physics, we need to use the exact scale. Okay, so in order to reduce the error, we use a lot of graph paper for the graphical methods. So normally when you use when you deal with the graphical methods, please use graph paper, because the graph paper already have its own scale, its own boxes, right? So that is very important. And one thing, and for sure, when you calculate everything, please make sure that the last part, okay, the last part or the last part that people tend to forget is unit. So in here, we're discussing about the questions that have kilometers. So in the end, at the last question, you need to calculate, and then you, let's say the final answer is 35, then you should put kilometer, or else you will get one penalty point. Okay, penalty means you have been deducted with 1 point from your final answer. If the final answer 35 kilometer should give you 2 meters at 2 marks, now you will only get 1 mark because you forget to write down the unit. Unit is very important in physics. Please, okay, whether you are dealing with the quizzes or tests, walaupun bukan final lagi, please put the correct unit. Unit is very important. Yeah, right? I must tell you, when you get wrong with units, you will sometimes you'll be punished in terms of marks. Okay, so please bear in mind. Okay, right. Let's go straight to the components of vectors. All right, every vectors that we are talking now must come with the components. What kind of components that we are talking now? Okay, so this is the kind of components. So for example, we have vector A over here. We have vector A, and vector A comes with the components of x. That that means it must come with the associates. Okay, vector A, let's say vector A is the main person. Okay, so the main person comes with its own bodyguard. Bodyguard is in x-axis is called components of x. Components of A in x direction. I need to be exact. Component of A. Why A? Because we are dealing with the vector A. Okay, components of vector A in x direction. Okay, component of vector A in x direction. And AY is what? AY is the component of vector Y in y direction. Sorry, components of A in y direction. Okay, so there are two components that must always associate with the every vectors. Okay, every vectors. And normally, how can we put this one? Okay, how can we know this one it associates our vectors? Okay, for example, this is our vector A, vector A. Okay, this is vector A. So first of all, you need this is the components of vector A in x direction. AX. Okay, and I don't want to draw here like the one that he did. Okay, but I want to draw here. This is AY. Can you imagine AX going tip to tail? And then what happened to the A? Vector A is the resultant of vector AX and also vector AY. AX, AY, then you will get vector A. So that's why we are saying now that vector component of X and component of Y, okay, is a component that builds up the vector A. Okay, so the main vector is based on component of X and also component Y. So in this case, okay, please not to memorize all of this. Don't memorize this. Okay, don't memorize it. Why? Okay, so basically in here, based on our figure here, they are saying that AX or component of vector A in x direction is A cos theta. Why A cos theta? Okay, so we use a lot of trigonometry functions over here. Say SOHCAH tua. Okay, SOHCAH tua. SOHCAH is the adjacent over hypotenuse. All right. So now try to imagine that this is your AY. Okay, this is the position of AY. Now you have AX. Okay, this is your angle, theta. All right. So kah tua cos theta is AX over A. Okay, cos theta is AX over A. So therefore, AX is A cos theta. Okay, and then if you look at AY, then you can get sine theta equals to AY. And AY over A. And AY is A sine theta. So that's how they get the A cos theta and A sine theta. But what happened? What happened if the vector is here, but the angle is here? You see, this is your y, this is your x. Then your AX right now, okay? So imagine this is AX, and this is AY. Okay, now your AX now have become A sine theta, and AY is A cos theta. Can you imagine? Yes. Okay, AX is A sine theta and AY is A cos theta. Okay, so don't memorize it. Okay, so to be on the shortcut, okay, you need to see where is your angle. You need to know where is your angle. If your angle is in between x and the vector, then your AX will have a cosine, will have a cosine. Everyone that have angle between it. Okay, if X have angle between if the component of X have angle if angle between vector and component of X, then component of X become cos. Everybody that have theta in between them, okay, between vector and also components, then it becomes cos, right? It become cosine. So I don't think you need to memorize AX must always equals to A cos theta, because this is one thing happens in your secondary school. Okay, people or your teacher, the physics you learn in the secondary school always tell you that the component of X is always A cos theta. A cos theta. It happens to me several years ago. And the students come to me and then always tell me that AX, sir, why AX is sine theta? I always believe that AX is A cos theta. Yes, because why? Because the angle written in your textbook or in your reference book is always here, but not purposely, in your associate level, or it may be in the university level. Okay, sometimes the angle is here. Then this one is already wrong. So you need to differentiate between the situations. Okay, but apart from that, we can calculate the magnitude. This is the magnitude. Magnitude A is equivalent to AX square plus AY square. That thing is, without any doubt, okay, it's always like this. Okay, a vector A can be had because when we apply trigonometric function, this one is the Pythagoras theorem. So AX square plus AY square, you square root, then you get magnitude of A. So that's not it. It's just a magnitude. So this is the direction. Okay, the directions. It's once again theta equivalent to tangent negative. How can they get tangent negative 1 AY over AX? That is because of A is because of the vector A, but Y by divide with X. Okay, Y as a numerator and AX as a denominator, because the angle comes from component of X. Here, the angle is come from the x-axis towards the vector. This is the angle. So that's why tangent negative 1 AY divide with the denominator AX. The denominator at the top here should be always referred to the one that the angle comes from. Okay, the one that the angle comes from, which is from the x-axis towards the vector. So you should always remember that. Okay, because people always tend to memorize without understand the concepts of magnitude and directions. This is what I want to highlight, because when you get this, every questions is easy. Really, it's easy. Okay, now you need to know the fundamental part of the calculation. Don't just jump to the calculator you want to do, but you need to know the process and how you want to think in order to get the answers. That's why it's very important for you to understand the basic first. Okay, strengthen your basics, okay, before you can easily get to the questions. Don't just jump to the question and then you want some easy students, okay, think like an easy one, okay, didn't think thoroughly, towards the questions. Okay, so you need to emphasize more on the basic part. Why? Okay, that's good. Okay, so vector A has a magnitude 7.25. Find its component for the directions of angles. So maybe they will give you some angles of 125. You should know where is your quadrant. Okay, 125 is quadrant 2 because we only have angle at quadrant 1 because 0 to 90. And how about quadrant 3 and quadrant 4? So you should know where is the, and of course, you need to know about all science teachers crazy. Okay, this is all positive for all sines or cos. This one, sine will always positive, cos will be negative. This one, tangent will always positive, everything will be negative. This one, cos will be positive, everybody will be negative. Okay, so that is how we apply some maths in the physics part. Okay. Okay, this is the examples. All right, you can try it on your own. Okay, where you can have a vector A. Okay, to get the components. This is the good exercise on how you can get the answers. Okay, maybe you can try it on your own. Maybe you can snap this question and then try with your calculators. Okay, in how you can get one, because you just punch in your calculator in order to get ax, ax. Okay, look at the value. Maybe there are some negative value in the answers. Why it can become negative? Why become negative? Okay, because you need to know that the concepts in the Cartesian coordinates. For example, this is x, it is y. Okay, when you have angles here, when you have angle here, okay, when you have angle here, your okay, this is all become positive. Okay, the components of ax positive, the component of ay positive. But let's say the vector is here. Okay, then this is your, okay, I should use another, okay. So when you have vector that comes from this part, so the vector, the ax is here and the ay is here. Okay, so ax become negative, ay become positive. So that's why, and the quadrant 2, ax is negative and ay is positive. Okay, the cut C here all become negative. Ay negative, ax is also negative. Okay, because according to the situation, because ay is going down and ax is going to the left. And how about D? Ax will be positive and ay will be negative. So that's why you need to know the positions of your vectors in order to get ax, ay, component of x and component of y. Okay. Okay, so this one is the examples of the Superman. Okay, find the horizontal and vertical component. Look at the questions. Okay, you can see here, and part A, find or calculate the horizontal and vertical component. Horizontal and vertical component of the D, which is 100 meters displacement of a superhero who flies from the top of a tall building along the path shown in figure 3.11a here. Okay, so meaning that the D is 100 meters, so this should be the component of x. And where is component of y? Here. This should be the dx, and this should be the dy. Why I use D? Because displacement. Okay, if you want to use AX, it's up to you. Okay, look at how they create here. So this is AX and also AY. AY is going downwards. Why? Because it depends on the vector. Like I used to draw after before this is because of A is going here. So A is come from this part. It's like a box. So this is okay. This is A, vector A, so this one is AX, this one is AY. So from here, AX and AY have become different. AX still positive, AY will be negative. So that's why when you calculate it here, okay, please punch in your calculator, try, okay, please, okay, take out your calculator, try now, okay. Is it necessary to put a negative? Okay, so basically, you didn't have to put the negative at the angle. So for example, you have AX is 100 cos 30, and you will get 86.6 meters. Okay, and another one is 100 sine 30, where the answer is negative. The negative now is the one that you should prepare yourself, because you already know that AY is going downwards. Dia ke arah bawah. So sebab tu dia letak negatif siap-siap. Tapi kalau nak guna cara dia, maksudnya you can use a trigonometry function, because this is in a quadrant 4. The quadrant 4, okay, the sign will be negative. All values of cos is positive. Simple. Okay, so in the end, you should know why it becomes positive and why it becomes negative. Look at the situations. I always tell students to look at the situations. For example, vector A is going downwards, so therefore we have a components of going to the right and also going to the bottom. To the right is always positive, to the bottom will becomes negative value, so that's why it becomes negative. But apart from that, the magnitude is always positive because it involves the square root, the square and also square root. And then in the end, we will get negative 21. Okay, based on our calculations, okay, this is AY, this is AX, okay, tangent negative 1, AY 10 divided by negative 25. So you will get negative 21.8. Definitely negative 21.8. Okay, so negative 21.8 is also equals to 158 degree. 158 degree. Okay, so you can check it on your own. 180 minus with 21.8, then you will get 158 degree. Okay, all right, so this is how they get the A cosine or A sine, A cos theta or A sine theta. So that's really depends on the situation. This is a very good examples. Okay, you can look here where the theta is at here, then AX become the value, AY become here. But if the theta is over here, then AX at AY will become A cos and AX will become A sine. So don't memorize all the value. Don't memorize X is always cos, Y is always sine. No. Right from now, don't memorize. Okay, sine. Just look at the where is the angle. Tengok di mana angle tu duduk, and then you know that is always related to cos. Okay, do you have any questions? Ada soalan?
No.
No, sir.
Okay. Then should I continue? Right?
Yes.
Okay, so this is adding vectors using components. Before this, we learned about components, and right now we want to add the vectors using components. Okay, for this is very good examples. All right, we use the same figures that we used to solve it using the graphical method. Okay, for example, if you still remember, A is the 5 meters and B is the 4 meters, but you need to calculate you need to use a graphical method where A is 60 degree and B is the 30 degree, if I'm not mistaken, 30 or 20, I'm not sure. Okay, but in here we use a components method. Okay, if the question doesn't state to use graphical or use component, then maybe you want to apply components, because components is more accurate compared to graphical methods. Okay. Okay, components is more accurate. So in component, we have, for vector A, we have AX and AY. For vector B, we also have BX and BY. So what can we do? We separate, okay, all the components into its CX and CY, because you know C is equivalent to CX plus CY square plus CX square. You square root to get the magnitude of C. Okay, to get the magnitude of C, you square root it. And you square it plus, and then you square root. So how to get CX? CX is based on AX and BX, AY and BY. And then you can get CX and CY, you square it, you plus, and then you square root it back in order to get magnitude. Okay, so let's look at how they did. Yes, this is the how you should be, how to solve the problems of components. Okay, so for example, here, okay, this is vector A. Vector A is 60 degrees. Okay, remember vector A, it also comes with the AX and AY. AX and AY. So this is the answer, 2.5, 4.33 meters. It is not necessarily to put the units during the calculations. Okay, tak perlu letak lah unit dalam calculation, takut jadi keliru. Right? To get you confused. But in the end, you should put the value. Right? So where is BX here? So BX pun ada, BY pun ada. So you need to calculate each one, BX, BY, AX, and AY. And then you can summarize it by you adding the vectors of CX, which is AX plus BX, and the vectors of CY, AY, and BY in order to get the value. And then afterwards, you can get the magnitude. This is where the magnitude. That is how the questions of solving vectors can be done, because sometimes the vectors just want to know what is the magnitude and the directions. What is the magnitude and the directions? Magnitude is based on the components. Magnitude is the number, is the value, and the direction is the theta. Look at the answers. Okay, can we compare it to our original one, the graphical methods one? Let's compare. Okay, by using calculation, we get 8.47, while by using graphical method, we have 8.75 meters, and theta is 45, and theta during with our calculation is 42.3, more precisely than our components calculations. But that really depends on the question, because sometimes they want you to use a graphical method. So that's why you need to really understood, or really read your questions properly in order for you to know which is the correct method, which is the given method. Okay, maybe they want to get you to know your skills in using ruler and protractor. So that's why they want you to use a graphical method. So there's, okay, we cannot we cannot think like what they should be. Okay, but you need to know both concepts, okay, precisely, in order for you to answer the problems. Okay, this is how they get all the values. Okay, this is all marks. Okay, I can show you where you can get marks. Okay, for example, marks. Maybe this one, you get 2 marks, so 4 marks at the components itself. Okay, and then at the magnitude, you will get another 2 marks, and maybe at the theta you get 1 mark. So at least 7 marks have already established during your final exam. So that is how. But if you tend to forget about the meters, you didn't write down the unit, then it becomes 6. And then you forget to calculate the directions, then it become 5. You get wrong in one of the components, then it will necessarily get wrong in terms of one of the components. So that's how it's very crucial to understand the concepts of vector. Vector it can be applied to every chapter after this, especially in chapters that involve motions, or should I call it as a mechanics. In mechanics, we use a lot of component vectors. Okay, when I tell you, when I state vectors, that means you need to apply all of this concept. starting from components, starting from magnitude, directions. Component, magnitude, direction. It always comes together, okay? When you talk about vectors, component, okay, magnitude, and directions. Three things that you need to master it, okay, when you talk about vectors. Okay, now we are here. Okay, this is another one examples. Okay, so let's look at these examples. A hiker begins a trip by first walking 25 kilometers, 45 degrees south of east. Okay, remember, once again, in the questions, they put or they want to trouble you just by giving you a direction of northeast west. Okay, so you can use your own Cartesian coordinates, and you need to apply. Okay, 25 kilometers. Where is 25 kilometers? South of east. Okay, so south of east should be here. This one. Okay, this is south of east. And then from here, you draw another imaginary Cartesian coordinate to draw B. Okay, so the next question, at which point, in the directions 40 kilometers, okay, 40 kilometers, north of east, north of east, okay, north of east. So you calculate, you do 60 degree, and then you draw, okay, it's going upwards at vector B. Okay, determine the components of the hiker. So look at how they try to break your the questions. The exact question is actually at C. Find the magnitude and directions. That is the main point. But at point A and point B, they have already give you some hint. So at point A, what you should do at first step. So you need to draw, you need to determine the components height. Okay, this question is very good because in part A and part B, it didn't jump straight away to magnitude and directions. Okay, it gave you some informations. Okay, what to do as the first step. Okay, the first step you need to draw in, you need to determine the components displacement. Okay, for example, they calculated AX and AY, BX and BY correctly. Okay, look at how they did correctly. Okay, for example, at vector A, okay, AX will be positive and AY will be negative. At vector B, okay, both will be positive. See? So look at the value with the negative value. Okay, why it becomes negative? I already tell you earlier. Okay, so now we have AX, AY, BX, and BY. Now, and part B, there is only part A. This is only part A. Okay, part B, determine the components of the hiker's total displacement. So they want to find Rx and Ry. So in the end, you will get 37.7, 16.9 kilogram. And lastly, they want to know about the magnitude and directions by using the uh, the equations of R equals to Rx square plus Ry square root. Okay, to get the magnitude. Then in the end, you will get theta. Theta is 16.9, okay, which is the Ry divided by tangent negative 1 Ry over Rx. Ry over Rx, tangent negative 1. So you will get 21.4 degree. Where is 21.4? It should be here. So this is your vector quantity. This is your resultant, and this is theta. Resultant vector spot. Theta is 24.1 degree. So that is all the component. You look at how the questions discuss. And this is how you did to the questions of the vectors, of solving the vectors using components. You must have a components, you must have a magnitude, and you must have a directions. It's a three concepts that can help you to to solve your problems in vectors. Okay.
So,
Yep.
um, yes, this one, the cos negative 45 degree. Is it necessary to write the negative sign?
No. If you ask me, then I would say no, because the cost, you need to know the concepts of or everybody need to know about the concepts of quadrant. Okay, because A is going to the, I'm not sure, southeast punya direction. Okay, kalau kita tengok A tu, vector A tu, it's simple. Kalau vector A ke bawah macam ni, contohnya macam ni, ke bawah macam ni, tadi kita akan tahu AX dia akan pergi ke sini. Ni AX dia, definitely. AY dia akan pergi ke bawah. So AX mesti akan dapat positif sebab dia ke kanan. Dan AY mesti dapat negatif sebab dia ke bawah. Simple. Cuba tengok B pula. Kalau B dia macam ni. So BX akan duduk belah sini. BY akan duduk sebelah atas. Jadi sebab itulah dua-dua dapat positif. So sebab tu saya kata theta ni tak perlu pun letak negatif atau positif. Dia hanya mengelirukan awak nanti. Tapi awak kena faham benda ni dia datang disebabkan oleh keadaan components vector tu. Boleh
Okay, thank you, sir.
Good questions. Okay, anyone nak ask lagi, nak tanya? Okay, so that is a very good examples. Okay, alright. So we have come to the end of our lecture in terms of vectors. Okay, this is the unit vector. The unit vector is the one that we use to use or to write down a vector in terms of directions. Okay, so how can we get here? This is the examples of the unit vector. For example, vector D, okay, this is italic, okay, vector D is 0i, 22j. Okay, I stands for direction in X and J stands for direction in Y. Maybe ada K lepas tu. Maybe kalau ada 4K, IJK IJK, dia jenis macam mana ni? Ni. J, I, J, K dalam yang ada jenis, ada topi. Ada topi macam ni. X, Y, Z. I, J, K. Simple. Okay, itu dia punya ni lah. Dia punya kalau I merujuk kepada X, kalau J merujuk kepada Y, Z merujuk kepada K. Dia menunjukkan tempat dia berada di mana. Okay, for example, macam ni. 23.5I negative 40. Okay, saya buat mudah lah. Macam ni. 4I plus 3J. Where is this vector A? Macam mana nak lukis vector ni? 4I, 3J. Okay. So you need to draw 4I in X directions and 3 units in Y direction. So dia akan jadi become, let's say this is Cartesian coordinates. 1, 2, 3, 4. So this is, okay. Dan 3J. 1, 2, 3. So lebih kurang macam ni. So the vector, it should be tempat pertemuan dia. Ini vector dia. This is vector A. Ini yang dinamakan unit vectors. So this is how you write down the vectors in terms of unit vectors. So you need to know the concept is still the same, X, Y, J. Cuma kalau biasanya vector dulu dibagi, contoh vector lain. Vector A is 22 centimeters to the right. Tapi saya tak nak tulis macam ni, saya tulis vector A is 22I. So kita dah tahu dah. Dia duduk dekat arah X axis. Simple. Okay, that's how the simples of unit vector. Okay, don't memorize all of these nonsense punya equations. Just remember the unit vector is very simple to show the directions of where is the exact place, the exact tempat itu di mana kita nak lukis vector. Simple, I know all of you maybe have a very bad memory in your ad maths or in your physics during your secondary school, but nothing's to be afraid of. Okay, nothing's to be afraid of. Okay, it's just a matter of unit vector in how for you to write down the places. Okay, tempat. Yeah. Okay, this is the good examples, right? And of course, you must come to the situations of like this. Okay, 0. For example, D1 and D2, where D1 is 0i plus 22j and D2 is 23.5i minus 40.7j, and then you need to simplify this one. So I with I, j with j, so you will get 23.5i minus 18.7j. But you can also calculate the magnitude of this vector D, okay, using this equation, which is this one. You just square it and also square this j in order to get the magnitude. So in magnitude, okay, the vector can be calculated in terms of I and j in terms of unit vector. So in the end, you should write down like this. Okay, D is 23.5i minus 18.7j. That is also equals to 30. Okay, the magnitude of D is 30. Definitely magnitude dia. So kalau kita tulis, kalau D, kalau ada arrow ni, maksudnya dia nak dalam vector. Tapi kalau D saja, maksudnya magnitude of D 30 meters. 30 unit. Simple, Okay, this is some another because we already learned about vectors. Okay, so vector, we have two things, which is vector multiple. We have addition of vectors, a plus b equals to b plus a. Okay, then we have subtraction of vectors. A minus b is equivalent to a plus negative b. So now we comes to the next part of the operational of vectors, which is multiplications and divisions. In multiplication, we have a dot product and also a cross product. Okay, so what is the dot product? Okay, this is your unit vector. Look at the unit vector. The unit vector that multiply with its own self is itself. Now you will get 1, but the multiply is x dot with y. Dot means sometimes like a simple darab. Darab saja, x kali dengan y dapat kosong, y kali dengan x dapat kosong, y kali dengan y dapat 1, x kali dengan x dapat 1. So macam mana situation dia? Macam ni, lebih kurang. Okay, macam ni lah saya tunjukkan. Macam contoh dah, 4x plus with 5y untuk A, okay, and B 3x minus 8y. So dia kata kalau what is A dot B, so kena kali lah 4x 5y kali dengan, tapi kali ni kita buat dot je pun okey, buat 3x minus 8y. So macam mana? Ni lah, ni kali dengan ni kali dengan ni. Betul, ni kali dengan ni kali dengan ni. Right? So dia akan jadi apa? 4x kali dengan 3x, dia akan dapat 12. Sebab x kali dengan x dapat 1 kan? 12xx. Okay. 4x kali dengan negative 8y, it becomes negative 32xy, it becomes 0. So plus 0. So x kali dengan y dapat 0. So y kali dengan y negative 40. So the answer is 12 minus 40 negative 28. Macam tu jawapan. So basically the vector dot product ni, nama dia dot sebab nama dia dot. Dot ni sebenarnya multiplication of vector. Sebenarnya vector kali dengan vector tapi dengan cara dot. Okay, cara dot dia akan dapat scalar quantity. Dia akan dapat scalar quantity. Nampak? Dapat jawapan akhir dia dalam bentuk nombor, bukan dalam bentuk vectors. Nampak? Jawapan akhir dia dalam bentuk nombor, dalam bentuk nilai. Tapi bukan dalam bentuk vectors. How about dot product? Cross product? Cross product dia lain sikit. Cross product dia melibatkan directions. Dia ada dua lah cross product ni. Okay. Ni vector A cross vector B. Okay. Vector A cross vector B. Right? So vector A ada value dia. A, X, Y, Z. And vector B, A, B, X, B, Y, B, Z. And then if you look at the final answers of vector A cross with vector B, you look at the final answer, dia masih ada lagi ni. What does it mean by I, J, K? Ini bermaksud jawapan dia mesti dalam vector quantity. Jawapan dia dalam bentuk vector. Kalau dia bagi A cross B macam ni. Dia ada dua dalam cross product ni. Cross product ada dua, dia ada macam ni, A cross B, vector A cross vector B, and another one is vector A cross vector B but in the modulus. In the modulus. This one you will get vector quantity. This one you will get scalar quantity. Ada dua benda dekat situ. First you can get vector quantity and another one is you get scalar quantity. I will not go further on this part, but you need to know that you can easily get from the question itself. Okay. Any questions so far? Do you have any questions?
Sir, nak tanya untuk graphical method,
Okay.
ada apa-apa syarat ke untuk kita letak skala?
Tak ada.
Tak ada, maksudnya boleh letak apa-apa nombor je lah.
Betul. Dia ikut kesesuaian situation. Contoh dia bagi unit 1 kilometer. Okay, 1 kilometer. Maknanya vector A ialah 5 kilometer ke arah kiri. Dia bagi tahu macam tu lah. Takkan kita nak buat 50 cm kan. So kita kena guna appropriate lah 1 cm yang boleh muat dalam kertas kita.
Thank you, sir.
Okay. Anyone? Okay, I think kalau tak ada soalan, kalau ada pun letak dalam chat box dulu. We need to take break 1 or 2 minutes before we go to the next chapter. Okay? Okay, stay tuned. Okay, so let's continue back to our lesson. Okay, so the next chapter will be motion in one dimension. Let me share the slide. Okay, this is motion in one dimension. Okay, before this we learn about units and so on, units, vectors and so on. One moment. Okay. So this is the units of chapter 2, which is the motion. You have a displacement, velocity, acceleration, one-dimensional motions. At least one of two things here that you can always uh, refer to your previous, or we can always refer to your textbook. Maybe you don't have a textbook, you can use your reference book back in your schools. Okay, displacement, velocity, acceleration. At least until one-dimensional motion, you can always use um your old textbook. Okay, doesn't different much with that books. Okay, but during free falling, then I will explain later in terms of that. Okay, so this is the displacement. I think you already know. I already explained about the displacement and the distance. Okay, the distance, the difference between distance and displacement is based on the reference point. Okay, so displacement of an object defined as the final point minus initial point. Final point minus initial point. All right. Okay. So the SI unit is in meters. Obviously, displacement and distance share the same SI units. All right. So for example, from A to B, for example, okay, this is A. Okay. Car at A and car at B is to N is considered to be 52 minus 30. 52 minus 30 is equivalent to 22 meters. Displacement always, if you look at the previous slide, displacement is a vector quantity. Okay, because displacement needs some directions. Okay, so like in C, when C to F, okay, giving here from C to F, C to F is a 40 and C is negative 60, or it's about negative 53 minus is negative 38. The answer is negative, okay, from C to F. So you need to get this is the final point, the XF, and then this is the XI. So the idea is a final position minus initial position. Okay, final position minus initial position. Okay, simple. Right? So therefore, the positive and negative it tells you about the directions. Okay, so this is the velocity, the average speed of an object over a given time interval, total length over total length over total time with the meter per second. And obviously, our velocity is a vector quantity. Okay, velocity is a vector quantity. In sometimes that related to velocity is speed. Speed is also length over time. Okay, this one is a vector quantity. Vector quantity. This one is a scalar quantity. Okay, speed is scalar, but velocity is a vector quantity. Okay, so although it share the same equation, but the concepts of velocity always relates with the displacement. But for the speed is always related to the distance. So that's how they get the difference between scalar quantity and vector quantity. Okay, right. So a turtle, for example, a turtle and a rabbit engage in a foot race over a distance of 4 kilometers. The rabbit runs 0.5 kilometers and then stops for a 90-minute nap. Upon awakening, he remembers the race and runs twice as fast. Okay, finishing the course in a total time of 1.75 hours, the rabbit wins the race. They calculate the average speed of the rabbit and B, what was his average speed before he stops for a nap. Okay, so the total average speed is 20, based on the path length is 4 kilometers, divide with 1.75, so is it about 2.29 kilometer per hour. Okay, it is not a SI unit, but with in this situation they use kilometer per hour. Okay, definitely it's not a SI unit, because the SI unit for the speed or the velocity is meter per second. Okay, you cannot use a kilometer per hour. All right. So it's stated here, finishing the course in total time, the rabbit wins the race. Okay, because the rabbit runs 0.5 kilometer then stop for 90 minutes nap. 90 minutes is considered to be how many hour? Okay, 90 minutes is about 60 plus 30, 1.5 hours. Okay, 1.5 hours. So then he runs twice as fast. So it increase more speed. Okay, and finishing the course in a total time 1.75. Okay, 1.75. Calculate the average speed of the rabbit. So the average speed we have already calculated. What was his average speed before he stopped for a nap? What was his average speed, meaning that speed of the rabbit before he stopped for a nap? Okay, before he stopped for a nap. So 1.75 plus with 1.35. Okay, so 175 minus 1.3, so it's about 0.25. Okay, okay, because it is before he stops for a nap. Okay, before he stops for a nap, so 0.25 hours. So that is total T1 and T2. Okay, time number 1, time number 2. Okay, this is the 0.5 kilometers, and then after that you stop for a nap. So that is another average, another speed, and another 3.5 kilometers with twice as fast, 2 times the speed in the first speed, in the first quarter of the speeds. So that will equal to 0.25 hours, because this is the only time that the rabbit runs. Okay, because most of the time the rabbit sleeps. So 90 minutes is considered to be 1.5. Okay, 1.75 minus 1.5, so you will get 0.25 hours. So this is 0.25 hours of running. So therefore the average speed will be 9 kilometer per hour. Okay, so this is the average velocity before this is average speed. Okay, then again we need to know that the average speed based on the displacement, the average velocity based on displacement, meaning that total displacement divided by total time. The SI unit will be meter per second. If an object moves in a positive direction, then the average velocity will be more than 0, will be positive value. And if object move in a negative direction, meaning going backwards, then the delta V, the average speed is less than 0. The average speed will be negative, because it depends a lot in the displacement, where the displacement always taking a final position minus with initial positions. Okay. Okay, graphical interpretation of average velocities. Okay, this is something else, but this one is due to when you are in the certain period of time, from time equals to 0 until time equals to 4. Look at here, look at the sketching of the positions versus time. So here we have time 0, so the position is 1 meters. Time equals to 1 second, the position is 3 meters. Okay, times 2 seconds, the position is 4 meters, and then time 3 seconds, it goes back to the positions of 2 meters, and then at 4 seconds it goes back to the negative 1 meters. So therefore, when we plot a position against time graph, so you can see that the graph is going up, okay, against time, and then at the 2 seconds, okay, it changed the direction. It changed the direction because the graph is going downwards. It changed the directions towards the negative. Okay, so when you are giving a graph, so basically the graph of x versus t will give you an average. Okay, but for the curve graph like this, okay, you need to apply some point. You need to apply. You need to do some what we call that as 1 point. Okay, so in order for you to calculate the gradient of the x versus t, or the gradient of the graph of displacement against time, you can get velocity. Okay. All right. So this is quite new. The instantaneous velocity, I believe you already, maybe you have been touched in terms of instantaneous velocity, but in instantaneous velocity, we calculated the velocity at a specific time. Okay, at a specific time, maybe at time t equals to 1. So basically, when you are giving the instantaneous velocity, sometimes the v or the x, okay, will be given in terms of, for example, 4t square minus 6t. Okay, so when you want to find the v, okay, the instantaneous velocity at time t equals to 4 seconds. So how can you do? Find v. Calculate v at time t equals to 4. It's very precise. So we need to apply instantaneous velocity. But before that, we need to do some things to this function, because this function represent position versus time. Position in the time t. Okay, so we need to do what? We need to differentiate dx over dt in order to get v. So therefore, the answer should be 8t minus 6. V is 8t minus 6. So at time t equals to 4, then you replace t with 4. So v become 8 times 4 minus 6. So the answer is 26. So this is the instantaneous velocity, meaning that you don't have, you calculated the velocity based on the specific time. Okay, apart from that, the average velocity, the average is just when you do some tangent to the curve of the graph, so you just calculate the average one. You just calculate you just do some calculations in terms of gradient. Okay, gradient dx over dt. Okay, but for the instantaneous velocity, is sometimes they will give you a position, but in terms of function. Okay, function as a function of position as a function of time. So you need to do some different and simple differentiations to get v. Okay, because you know from x position we will get v. Okay, and from v we will get a. Okay, this one is dx over dt. This one is also dv over dt. And we can also get back by square root it, by integrate it, dv over dt. And also we integrate to get dx over dt to get x. So it's simple. Okay, but You must know that the average or the instantaneous velocity, okay, the average comes from the gradient. The instantaneous velocity sometimes comes with the simple differentiation. Okay, this is the good examples. A train moves slowly along a straight portion of track according to the graph of position versus time. Okay, look at the position versus time. Position x versus t. You will only have two graphs, x versus t and v versus t. The same goes when you learn motion during your school days. Okay. Find the average velocity for the total trip. The average velocity for the total trip. Okay, so the average is you get the total position, total length, which is 10 meters. How you can know how you can do this 10? Because starting from 0 until 10. Okay, is here at point C you have 10. So you get 10 over 12 seconds. 12 seconds is from 0 to 12 seconds. Okay, total length divided by total time. So you will get 0.833 meter per second. How about B? The average velocity during the first 4 seconds. So the first 4 seconds, then you need to apply the same gradient, but only for the first 4 seconds. Where is first 4 seconds? Here. Until here only. So this you need to calculate the gradient of from 0 to A. So using the graph 4 divided by 4, you will get 1. Okay. And then the average velocity during the next 4 seconds. So the next 4 seconds is from A to B. A to B is 4. The position is 4. The final position is 4. So definitely 0. 0 divided by 4 seconds. So you will get 0. Okay, and then the instantaneous velocity at time 2. Look at the questions. The instantaneous velocity at t equals to 2 seconds. T equals to 2 seconds is where? Okay, t is equals to 2 seconds. Is here. Okay, look at where. So is time t equals to 2 seconds is over here. So time t equals to 2 seconds is okay. What is the gradient here? Is 1 meter per second. Straight away you can get the answers. If you do not have the answers, then you need to calculate. And then the instantaneous velocity at time t equals to 9 seconds. Look at where is the 9 seconds here. Okay, it should be at the curve graph. So you need to use some tangent. Okay, tangent meaning that you need to touch one point at least at the curve, and then you do some simple triangle in order to calculate the gradient. So 4.5 minus 0, 4.5 here, minus 0, divide by 9 minus 3. 9 minus 3, 4.5 minus 0, 9 minus 3. So you will get, okay, 0.75 meter per second. Okay. Okay, so this is another equation, another examples. A jet engine moves along an experimental track, which we call the x-axis, as shown in figure 2. We will treat the engine as if it were particles. Okay, its position as a function of time is given by the equation x. Look at here. Okay, they have x as a function of t. Okay, they give x, but in terms of function a t square plus b. So as a function of time, yeah, where a is a 2.1 and b is 2.8. So basically the equation is x equals to 2.1 t square plus b 2.8. Okay, and this equation is plotted in the figure. Determine the displacement of the engine during the time interval t equals to 1 to t equals to 2. Simple. Then you replace the value of x with the value of function of x as a function of time. So you put 3, you put 5, then you calculate it. Okay, so the difference is 33.6 meters. And B, determine the average velocity during this time interval. The average of velocity. So the maximum is where? It's 33.6. Okay. Maybe they use some from at the this time interval 3 to 5. They means that in time 3 to 5 is obviously here until here. Okay, so you need to do some simple triangle to find the gradient. So the triangle is 33.6. Okay, and obviously 5 minus 3, 2. So you will get 16.8 meter per second. Okay, so determine the magnitude of instantaneous velocity. Instantaneous velocity is here, given by x equals to at plus b. So when you do some simple differentiation, now this one vanish. That's left only 2at. Then you replace this t with the 2.1, sorry, or 5 seconds, and then this a is 2.1, and you will get the instantaneous velocity 21 meter per second. Okay, so must do some simple differentiation. If you are given a function of v, then you can straight away use that function. But in this case, the instantaneous velocity is calculated based on displacement, function of displacement against time. Okay, so this is the acceleration. Okay, an object accelerates whenever its velocity change, no matter when its velocity increases or decreases. The average acceleration A during this time interval is the change in the velocity delta V divided by delta T. Okay, so the average velocity, the average acceleration. Same goes to velocity. We have average velocity. Okay, we have average velocity and we have instantaneous velocity. Okay, and also we have average acceleration and instantaneous acceleration. Okay, the concept is still the same, but the unit are different. Okay, the velocity is meter per second, while for the acceleration is meter per second square. Okay, so the acceleration, increasing speed, and deceleration. Okay, you know about the acceleration, how it can increase the speed, or when it decelerate, it becomes decreasing the speed. So the acceleration is also falls under vector quantity. So therefore, when it become positive or negative, it means something. Okay, the positive and negative will tell you the directions of the accelerations. Okay, so this is the instantaneous acceleration with the time interval delta t. The same goes to, can we apply, because when you are given v as a function of time, v equals to, for example, 3t square plus 6. Okay, so you need to do some differentiation to get a. So a is equivalent to 6t. So now, if you are given time, let's say time t equals to 5 seconds, then you just replace this one. Then your A will become 30 meter per second square. Okay, this is the examples 2.3 taken from your textbook. Okay, a baseball player move in a straight line path in order to catch a fly ball to hit the outfield. His velocity as a function of time is shown in figures. Okay, find his instantaneous acceleration at point A, point B, and point C. Okay, obviously they want to find the instantaneous acceleration. If the questions I've already plot the graph for you, so you just need to do some gradient. Take some gradient. So at point A, it falls under this gradient. So you need to calculate this gradient. So which is 4 minus 0, 2 minus 0, you will get 2 meter per second square. Look at the unit. The unit is very important. Okay, don't just simply put the meter per second, then you will get wrong. Okay, and the acceleration at point B obviously is the 0, because velocity is not changing. Okay, velocity is not changing from t equals to 2 and t equals to 3. And then afterwards, at point C, now we need to do another triangle here. So in order to do that, okay, you can see here when the velocity decreases, so the value of the acceleration will become negative. This is what we call deceleration. Ya, pecutan. Okay, deceleration. All right. So the most important thing when you deal with the motions is you need to apply. Okay, this is where the concepts of constant acceleration. Constant acceleration meaning that the acceleration is kept constant. The value of acceleration throughout the system or throughout the question is always stay the same. It's always the same. Then we can apply for one-dimensional motion of equations. Okay, what type of equation? Here. Okay, these equations, okay, I believe that you already familiar with this equation. V equals to V naught plus AT. Maybe another ones, or maybe at your school you use V equals to U plus AT. V square equals to U square plus 2AS. Or maybe you will use like S equals to UT plus half AT squared. Okay, but bear in mind when you come to the university level, so some things need to be changed, some things need to be done to your whatever you memorize during your school days. For example, U now is the initial velocity. So in here we use V naught, initial velocity. A is the same, V is the final velocity, then okay. And how about S? S is the displacement during your time. But in here, we can write down S as a function of X ataupun Y. We can use X or maybe you can use Y. Okay, for X and for S. Okay, so that is two different things between your what you memorize during your school days and what we learn in Asasi level and perhaps during your degree level. Okay, so you need to know that this is a very important equation when you deal with the constant acceleration. Always look at the keywords that says about constant acceleration during in the question itself. Then you know you can apply all these equations. If the questions doesn't state any parts of the question, okay, yang menunjukkan dia ialah constant acceleration, then please, okay, you need to use other equations. But this equation, all of this, okay, can be done or can be used when the acceleration is constant. Okay, then you can use this value. Okay, so it's very good, okay, if you can memorize, okay, because it gives you some confidence. Okay, confidence. Of course, when you deal with the final exam, maybe you will be given a appendix, but it should be a big advantage for those who can memorize. V equals to V naught plus AT, V square equals to V naught square. This one is good, same like V equals to U square plus 2AS. Look at here. Okay, they replace S as delta X. Delta X. What is delta X? Delta X is X F minus Xi. Okay, so the delta means the different X, okay, or change in X, change in position, change in displacement. So that's why they use the delta. Okay, because S here is just a value. Okay, if the questions give you one place to one point, so you obviously know. Okay, let's say from point A to point B, the answer is 10 meters. So you straight away can put S as D. But occasionally, the questions during your Asasi level, maybe they will tell you about the ball rolling from point A 10 meters until 20 meters point. So it's not 10. Okay, but why get 10? Because of 20 minus 10 meters. So you will get 10. So sometimes this one, okay, they didn't straight away give to you 10 meters. So that's why we need to change a little bit what you have learned during your school days. So right now, please use this kind of equations, or uh, this kind of equations that replacing u and also s. Right?
Sir,
Yep.
dalam exam nanti ada bagi helaian formula ke?
Ada. Belakang sekali. Dalam final exam, look at the last page of your final exam, then given to you appendix. Appendix tu lah ada semua equation. Semua equation yang penting-penting saja. Bukan semua. Bukan semua. Dia ada equation. Sebab tu nanti saya akan bagi throughout the semester, saya akan bagi contoh appendix. Maknanya appendix ni lah yang kamu akan tengok. Ni je yang ada. Kalau lebih pada tu, kamu kena hafal ataupun kamu kena derive sendiri. Okay. So that's very crucial lah. Okay. So this is how, okay, you look at the questions. Okay, I don't want to go further on this part. A constant rate of 5 meters per second. This is what we call constant acceleration. Then you can apply all the necessary equation. Okay, look at the questions. Constant speed. Okay, this one is not constant. A is not constant, but throughout the questions, it states constant accelerations of 3 meters per second square. How long does it take for the trooper to overtake? It's very good examples. Please, when I put these slides, okay, in your Google Classroom, I already put all the slides inside your U-Future. You can download it at your own. Okay, download it on your own. At least until week 14, I already put it. Okay, so you can you can download every slides of my during my lecture, so you can easily refer it. Okay. Alright, so this is the equation of a straight line under constant acceleration. Remember, this one is a velocity as a function of time, displacement as a function of time, and this one is a velocity as a function of displacement. There is no time in this equation. Look carefully. Okay, so these three equations, okay, please always put it in front of you when you want to solve the question, when you try to solve the problems. Because sometimes one question needs you to use maybe two or three equations together. And it's just not a matter of one questions, one possible equations, then you get the answer. No, maybe you need to use a few equations in order to get one answers. Okay, so please always have a mindset that equations will help you, but not just one equation. You have a lot of equations. Maybe you cannot equation number 1, you use equation number 2 or number 3. So you must come, it always comes that so that you will have a very big opportunity to solve the problems easy. Okay, all right. So I think I'll stop here. Maybe you need to watch some videos regarding the free falling objects. Okay, free falling objects is very good understanding in terms of motion. Before this, in the motion in one dimension, what does it mean? It means motions that move left to right only in x axis alone, just x axis, or in free falling just in y axis. X ataupun Y, tapi dia tak campur. Later on bila kita belajar nanti, dia akan belajar motion in two dimension, then dia akan bercampur dulu. Okay, sekarang ni it's just a matter of motions in one dimension, is either X or Y. Is that it? Okay, simple. Please, okay, your job, your homework is to look at all the possible pre-recorded videos for the free falling objects and also motion in two dimension, because that is what I want to teach you afterwards. Okay. Okay, any questions so far?